we're going to spend a little bit of time looking at some of these notes for 8.4 and really underline this right here on this first page, lesson 8.4. Underline the word properties because that's what we've got to learn. There are 3 properties we need to learn, and then it's a matter of applying those 3 properties the best we can in a few different situations. So we kind of looked at this warm-up yesterday. The only one I want to focus on right now is the last 2. For just a second, if you were to take this into your calculator, I think I did, type this log base 525 squared into your calculator for me and tell me, actually, people in the back row, type that in your calculator. Front row, type this one into your calculator. I want to see if they equal the same because this one and what they equivalent to gives us an indication of one property. Back row, what's that give us if you type that exactly in your calculator? All right, you did not type it in correctly, I'm afraid. Front row, what does this one give you if you type it? All right, so the front one gives you 4, or excuse me, number 5, which we did on the front. Back row, anything else we can get with this one? 4. Should get 4. And what is the difference? If you look at 4 and 5, the difference between these two, on 4, there is an exponent right here on this value, and on 5, that exponent is gone, and it seems like it can be brought right up there in front, and that is the same thing. So this is, from 4 to 5, this is a way of expanding or condensing, depending upon which way you're going. We're going to talk about that. But what I want you to notice is, when you expand or condense a logarithmic expression, you're not changing its value any. Your calculator, in other words, your calculator will give you the answer to some of these, whether they're expanded or condensed. So we'll kind of look into that. This one right here, number 4, to kind of explain why it equals 4. Log 525 squared equals some value, equivalates to some value. This value, that value right there would be the exponent of the base, the 5. So we're saying 5 to some power equals 25 to the second power. And if I was solving for that x right there, I could take this 25 and change it to 5 squared so that I have a common base. 5 here, 5 here. Power on power, what do we do? Power on a power, we multiply. So 5 squared makes 5 to the 4th. Now, hopefully this makes sense to you. 5 to what power equals 5 to the 4th power? 4. So this value is 4, you agree? So taking this logarithmic expression and writing it out in exponential form to solve it, we get 4. Or by just typing it in our calculator, we get 4. All right, so using some of this stuff, let's talk about the 3 properties. Now turn the page. Here are the 3 properties you're going to learn today. Properties of logarithms. There's 3 of them. This first property says, so first, label this like this. Put an arrow right here and label that arrow expanding. If I'm going from the left of these equal signs to the right, that's a process known as expanding the logarithm. And then label an arrow going across the top, or put an arrow this way going back to the left, and label that condensing. So if you had your expressions this way and you went back to something like this, using the property, that would be a process of condensing. So how I could expand, if I have a log with a base b and some value right here, I could write that same logarithm as 2 logarithms added together. So a quick example. If I had log base 4 of, let's just say, 10, the value 10. I could write that as log 4 5 plus log 4, sorry, that's right there on the corner, log 5, 4 plus log, log base 4, 5 plus log base 4, what? What would that value be right here? This is a 10. I'm expanding something, some value. Nope. 2. Very good. Because these two things, if I have them separated out or expanded out with a plus sign in between, I could condense it back by multiplying them. For two things that are multiplied, I could separate them out with an addition sign in between. See that example? We'll do some more examples of that. So that's the product property. If there's things multiplied, you can separate or expand them out with a plus sign. The quotient property says if two things are divided, you can separate them out with a minus sign. So I could do the same thing over here. If I had log 410, I could go log 4, this would be, if I was dividing, I could do log 420 plus log 4 what? Not plus, minus log 4 2, right? Because 20, if I condense that down, 20 divided by 2 would be that 10 again. And it's not always like this, but this is just a way of understanding it. Things that are divided, you can separate out with a subtraction sign. And then the thing that we saw here at the beginning is the power property. If there is an exponent right here, I can expand it out by bringing that exponent in front of the log. So if you have an exponent on your value, you put it in front. It doesn't change the value. So here's an example of condensing. 2 logs with a minus sign is brought down to log 2, 2. Which one is that an example of? What property? It's right there below it. That would be an example of the quotient property. Since it's subtracted, you can divide 8 and 4 and write it as 1 logarithm of 2. See that? I'll give you some examples here in a minute. Here is an example where 2 properties are being used. This log base b x to the third y could be separated out. X to the third and y are multiplied, so we have them separated out with addition. But what else is going on? Not only is there addition to separate them out, we brought the exponent off the 3 and put it right here in the front with the power property. So that's just hoping I want you to see what the different properties are, how they can be used. There's how the quotient property can be used. Here's how the product property can be used, separating these two variables. Here's how the power property can be used. I want to give you some examples, let you try. Let's look at one more, a little more complicated before I give you the examples. Here's one of your notes. These notes are good. I like these notes because there's a lot of examples there, because there's a lot of different things to think about. Look at this one right here. You got a numerator, you got a denominator, so it's not just one thing divided by another. So the first thing we could do is we could use the quotient property and put the whole numerator minus the whole denominator. See that? But we can go farther. We can now take this, just the first logarithm, and draw some lines here. Separate it out to these 2 logs, where you have a 7, and you have an x to the third. And we go one step farther by bringing the x to the third, putting the 3 in front. So now we have log 2, 7 plus 3 log 2x, still minus log 2y. Down there at the bottom of your page, we're going to try a couple of these. We're going to try to expand. Let's try to expand this one. Log 7 6x to the third y. Give you a chance. Now, there's not a base there, so what kind of log is that? Common log. If it was ln, it'd be a natural log. Good job. And so it's an understood what? 10. You don't need to know that, but just so you're wondering, hey, where'd the base go? Remember, that's a common log. So try to expand this. You're going to use a couple different properties. Give you a second to do this here in your notes. What would we do? One of y'all help me answer. Okay. What'd be the first log? Log 6. Then what mathematical sign? Plus. Very good. Then what? Very good. 3 log x. 3 comes front. Then, very good. Using two properties, product property and power property. That one to me is a good, easy start. Like, okay, I can do that. I can do that. I can get that. I like to take a look at this one. Log x over y z. So that was example 1. Here's example 2. This one's not exactly the same. I might have wrote that kind of weird, but x over y z is the whole value. It's a common log again. Actually, out of your homework, that's actually log base 2. Okay, so this one has a quotient symbol or division symbol, so it's going to be a little bit different maybe. But this one has a nice little wrinkle to it, makes you think a little bit more. Somebody, what would our first thing be? Log x, then what? Okay, so here's the question. I saw this earlier. When you first look at that, you go, wait a minute. No, that ain't right. It's the first one, the numerator minus the denominator, right? So this part right here would be the numerator. This part right here would be the denominator, right? So honestly, I have to think the denominator is multiplied. So could we say we could add these two? So if we did, but watch, if we did add them, then we would want to consider the fact that it's the numerator minus the denominator. So if it was that, but watch what happens. If it is the numerator minus the denominator, then you would simplify it down to that. Because you would distribute the minus sign, wouldn't you? So if you wrote log 2x minus log 2y minus log 2z, you're actually writing it correctly because it is this whole thing, it's the numerator minus that, and because down there it was just this plus this, that would distribute through and make it all negative. That's a little wrinkle. That's what that is. That's an interesting little wrinkle to that. But that's how it would work mathematically. Okay, kind of turn it up a notch. Now I'm gonna give you two more. Like actually, I'm gonna go straight to the. I'm gonna go straight to what I think is the longest one. When I first saw it on the page, I go, ooh, that's got something going on. Can we do it? And we can. So it's this log. It's a common log, no base. Square root. Come up here a little bit. Square root of 2RST over 5W. I'm going to kind of get you started here just a second, though, because, okay, we got three properties: power, product property, quotient property, and a power property. None of those properties say, here's what you do with a radical sign. But you've learned something in your Algebra 2 year with radical signs that could take me to one of those three properties. What could I do with this radical sign that could get me to where I could work with one of those three properties? What I'm asking you is, could I rewrite this? Good guess, but no. I just want to rewrite the square root of this thing another way. So, to the 1/2. Let's rewrite it. Oh. Let's come right here. Write it log parentheses 2RST all over 5W. Instead of taking the square root of all that, raise it all to the 1/2. Because if I raise it all to the 1/2, that's the same thing as taking the square root. Right? We learned about going radical form to exponential form. Now I can do something with that power. What would I do with that power? Yeah, go ahead and move it up there. You can either go ahead and move it up, or you can distribute it through. But if you just move it up, just remember it's on every log. So now you have a 1/2 log 2RST all over 5W. Now that 1/2 is going to follow that log. It's not on just one of them, it's on all of it. So look at how this thing expands out. We have a 1/2 log, what? 2 plus a 1/2 log R plus a 1/2 log plus a 1/2 log. Then what? Well, that's a 1/2 log 5 minus 1/2 log W. That's right. That one expands out. I know my writing's kind of bad, but the radical sign's the most tricky part there in the beginning. Hey, what do I do with the radical sign? By noticing we can make it, it's the same thing as raising it to 1/2. Then I'm able to put it out right there as a power, bring it to the front, and just carry it through. So it does look weird. In every one of those, it's a matter of applying that property different ways. So that is the process. All these are just expanding. All right, so go back to your notes. Here's some great examples. What's great about this, I showed you 3. Here's some real more simple examples. This one expands with subtraction. That's the quotient property. Here's another one that expands with plus and then putting the 4 in front. That's the power property. Then turn the page. Then we get into condensing. Log 6 plus 2 log 2 minus log 3. If I was wanting to condense that, step 1, I could bring the 2 back here, make it 2 squared. And then you could write this. This is 6 plus that, so that's 6 times the 4 minus the last part, so that'd be the first 2 multiplied all divided by the 3, which is 24 over 3, which is 8. By the way, that's all right here. If my writing is poor, you can see it there as well. But what's interesting, if you took your calculator, which you can, if you were to type that into your calculator, or you type that into your calculator, do you think you get the same value? You do. Expand it or condense, it doesn't change the value of the expression, just a different way of writing it. It's like 0.9 something. Okay. Somebody's checking it. All right, so let's talk a little bit more about condensing. So if it says write each logarithmic expression as a single logarithm, this one right here, 20 minus 4, that means you would divide them, it'd be log 3, 5. So that's condensing back to a single logarithm. These two to here. Here's one with plus and a number in front, so if we wrote them back together, We multiply this one times this one, so x to the third times y. Power property and product property brings it back together. Okay, we're going to do a couple more examples, then we'll stop for today. So this would be the process of condensing. Easton, what would that, if I condensed it to 1, what would I write? So what would it be? Which is 12. Yeah, that's a real simple one, can condense down to 1. All right, you guys try this one. So, first thing we would do, we would divide here, right? And then multiply to that. So that would be log 15x. 60 divided by 4 is 15. Multiply it to the x. Good with that one? Now I'll let you think. That's 1, 2. I'm going to give you one of these that makes you feel like you got to think a lot, but if you understand what you're looking at, then maybe it's not that hard at all. All right, here we go. I don't know why I put parentheses in the 3x. It's not required, but 1/3 log 3x plus 2/3 log 3x. Apply the properties. I'll give you just a second. I want to get a couple answers from you. Anybody feel confident in their answer? What else? What? Okay. What did you do with the powers? I see what you're saying. You have to bring them around front and then do 1/3 and 2/3. So, let's say we use the power property. Put them back as exponents, right? Then if it's plus, we're supposed to multiply, correct? So that would be 3x to the 1/3 times 3x to the 2/3. What's one, what do we do when you multiply a common base? Add them? That's right. So how many, what would that make? What's 1/3 and 2/3? 3/3, which is 1. So hey, log 3x is right. How did you do it? Like, did you say you put the 1/3 to the 3 and the 1/3 to the x? Or you did the third root? Okay. Oh, I see. Yeah. Might have got you there a different way. Okay. I'm, does this make sense though? If you bring these over and you have a common base, what you could do there? Cool. Okay, so this is condensing, writing a single logarithm. It's new. This is something you haven't ever done before, but it's fun, it's different. We'll be trying this soon. Let me go ahead and hit stop.